Hello everyone, my name is Shivani Rajput and today we will be discussing quadratic equations here. So before discussing quadratic equation, let's discuss what a polynomial is. So for the definition of polynomial, we'll use the variable x. Let's say we are discussing a polynomial in x. It will be denoted by f of x, and it will be if we are discussing nth degree of polynomial here, so we will write an into x raised to n plus an minus 1 x raised to n minus 1 plus an minus 2 x raised to n minus 2 plus till a1x plus a naught. Here, for this polynomial to be nth degree polynomial, we want x raised to n to be there, and hence the necessary condition is that an should be non-zero. If the an is 0, then the coefficient of x raised to n will be 0. This term will vanish and we will be left with an minus 1 x raised to n minus 1, which will make this polynomial of degree n minus 1. And we want the polynomial to be degree of n. So for the polynomial to be degree of n, we cannot have an to be 0. Hence the required condition is an is non-zero. And all the other ai's can be real numbers. They can be rational, irrational, integer, non-integer, positive, negative, whatever they can be. Only the condition mandatory is that an should be non-zero, because if an is 0, then the polynomial will be, the degree will be reduced to n minus 1. So this is the general form of an nth degree polynomial. Now there are types of polynomial. So for if all the ai's are 0 other than a naught, then it will be a constant polynomial. Constant polynomial when all the ai's are 0 other than a naught. A naught is non-zero, then fx will be called, and all others ai are 0 for I is not equals to 0. If I is not equals to 0, then all the ai's are 0, and if I is 0, that is a naught, that is non-zero, then fx will be a naught. This is called a constant polynomial where no power of variable exists, only variable raised to 0. This is called constant polynomial. If the degree of polynomial is linear, so according to the degree of the polynomial, we can define as, suppose this is degree and here is polynomial. According to the degree of the polynomial, if degree is 1, the polynomial will be linear. If degree is 2, polynomial will be quadratic. If degree is 3, polynomial will be cubic. And if degree is 4, the polynomial will be biquadratic. And similarly, we can define names of polynomials for various degrees. Now let's move on. Further, if we are talking about the nth degree polynomial, that is f of x is equals to an x raised to n plus an minus 1 x raised to n minus 1 till a1x plus a naught. Here, since the degree of the polynomial is n, highest power variable is x raised to n, so the coefficient of x raised to n will be called leading coefficient. Leading coefficient. This is an important term for the definition of polynomial, as if we have the leading coefficient to be 1. If leading coefficient is equals to 1, then it will be called monic polynomial. If leading coefficient is 1, then our polynomial will be called monic polynomial. Now let's move on to the quadratic equation. What is a quadratic equation? What is an equation? If a polynomial is equated to any constant, then it is called an equation. Now if we are talking about quadratic equation, then quadratic equation, if the quadratic polynomial is equated to a constant, that is ax square plus bx plus c is equated to 0. We can also equate it to some other constant other than 0. Suppose if we are equating it to d, then in that case we'll reform it to ax square plus bx plus c minus d. T will transform to the left hand side and we'll get RHS as 0. So this is the standard form of a quadratic equation. Ax square plus bx plus c is equals to 0. Now what else can be defined for a quadratic equation? As we all know that the roots and zeros of a polynomial and roots of an equation. What is the difference between these two words? Roots and zeros. Roots and zeros. Roots are for the equation and zeros are for the polynomial. Though they are the same thing, roots are for the equation and zeros are for the polynomial. If there are value of variables that satisfies an equation, then they are called roots of the equation. If there are some value of the variable for which polynomial becomes 0, then we call it 0 of a polynomial. Now moving on to next section. If the since the quadratic equation has degree 2, it will have 2 roots. So roots of the equation. Suppose we are considering ax square plus bx plus c is equals to 0. This is a quadratic equation. Since the degree is 2, it will have 2 roots. Suppose roots are x1 and x2. Then sum of roots is defined as x1 plus x2 is equals to minus b upon a. Product of roots x1 into x2 is defined as c upon a. If we have to find difference of roots, then how do we find the difference of roots? Given the sum of roots is minus b by a and product of roots is c by a. If we want to find difference of roots, that is x1 minus x2, then we know that squaring this side will give x1 plus x2 the whole square minus 4x1 x2. x1 plus x2 का whole square is b square by a square minus 4c by a. If we took the LCM here, a square b square minus 4ac, and hence x1 minus x2 will be under root of b square minus 4ac upon a, that is under root d upon a. So this is difference of roots for a quadratic equation. Sum of roots is minus b by a, product of roots is c by a, and difference of roots is under root d by a. That is all for today's session. Thank you.